All right, there was another request for some help showing how to do the domain questions from the worksheet that I posted today. I'm probably going to do this in two sets. I will probably do the odds and then do the even separately just so the video doesn't become too long. So let's see. Problem number 1. Find the domain of the function, write your answer in interval notation. So things that I want to look for in problem number 1. I want to look for square roots. I don't have any. I want to look for fractions. I don't have any. Your domain in this case is not restricted at all. So any x value in the whole wide world will work. There's no restrictions. So x can be negative, positive, decimal, fraction, 0. It's all fine. There will be no issues. You're not going to run into imaginary numbers by having a negative under the square root. You're not going to run into undefined numbers because you don't have any fractions. So yeah, that's it for number 1. Number 3, I'm going to slide on down. First thing I look for is square roots. I have none. Second thing I look for is I'm going to look at my fraction here. My fraction has a denominator of x plus 1. And because of domain and everything else, I know that this cannot equal 0. All right? Because if that denominator equals 0, then I would have 1 divided by 0, which is undefined, and then I have 2 plus undefined. That's not a terribly useful answer. So we want to avoid 2 plus undefined. To solve this little equation here, solve it just like normal, and you're going to tell me that x cannot equal negative 1. If you like using your number line to kind of demonstrate to yourself what's going on, you could use an open circle here. I just use the parentheses because that's what I'm going to use for my interval anyway. And basically every number in the whole wide world works except for negative 1. So we're going to go negative infinity to negative 1, then negative 1 to infinity, and there is your interval. All right, so that's what happens if you just have a single fraction there. By the way, the 2 didn't matter. It's just going to say 2. All right, so problem number 5, things I'm looking for. I'm looking for square roots. I have none. I'm looking for fractions. That I have. So I need to take this denominator and make sure that it cannot equal 0. All right? So 2 minus what is going to equal 0? Well, this is going to tell me that x cannot equal 2, right? Because if I put a 2 in here, 2 minus 2 is 0, and then I run into this whole divide by 0 nonsense, and we don't want to do that. All right? If you need the number line, use the number line. You can also just know that you're going to go from negative infinity to 2, and then 2 to infinity. All right? Every number works except for 2. We had to throw it out. And I think there's one more. Ooh, there is. Ooh, number 7. All right. So first thing I look for is a square root. I have one. And so within the square root, I just want to focus on the expression. Now, this, you have to be careful because if the square root's in the numerator, it's a little different than if it is in the denominator. In this case, because the root is in the numerator, this root could be 0, right? 0 divided by something is okay, and this root could be positive. So because it could be 0 or positive, we're going to say that x plus 6 has to be greater than or equal to 0. So greater than 0 is going to make it positive, equal to 0 is 0, and that's okay. So x is greater than or equal to negative 6. So that part's done. Separately, I now want to look at my denominator here. And if it's possible to factor it. So we've got x minus 3, x plus 3. And what I want to think about is what values would make these factors equal to 0 so that I could throw them out of the domain. So if x equals 3 here, that would be a problem. If x equals negative 3 here, that would be a problem. So x cannot equal 3 or negative 3. For problem number 7 here, I would really definitely recommend using a number line of some sort just to keep everything organized. So we've got -6, -3, and 3. No, I'm not going to worry about making sure these are spaced perfectly, not the purpose. So I know from this first part, x has to be greater than or equal to -6. So I'm going to use a little bracket here at -6 and shade greater. Okay, so that's the first part. The second part says that as I'm shading along here, when I get to -3, I need to throw -3 out. When I get to +3, I need to throw +3 out. So each one of these is going to be its own little interval, and so you want to make sure that you have them all. Our shading starts at -6. We're going to go to -3, throw that out. From -3 to 3, throw that out, and then 3 to infinity. Be careful where you use the parentheses. Be careful where you use your brackets. In this case, we want to use the bracket here with -6 because it was equal to. And then with these two, with the -3 and the +3, you have to use parentheses to show that it cannot actually equal that value. All right, so I'm going to go ahead and close this video off, and then I will pop up a second video going through the other half of the problems. I hope this has helped a little bit with figuring out domain given a function.